What are the best practices for hyperparameter tuning in regression? Imagine trying to fine-tune a musical instrument. If you don't adjust the strings correctly, the sound won't be right. The same idea applies to tuning regression models in machine learning. When working with regression algorithms, especially in supervised learning, choosing the right hyperparameters can make a big difference in how well your model predicts. Hyperparameter tuning involves selecting the best settings for your model before training begins. These settings include things like regularization strength, learning rate, or the number of features to include. The goal is to find the combination that gives you the most accurate predictions on new data. Start by creating a simple baseline model without any tuning. This gives you a point of comparison to see if your tuning efforts are paying off. Next, decide on a tuning strategy based on your resources and the size of your data. If your dataset is small and your model simple, grid search can be effective. It tries every possible combination of hyperparameters but can take a lot of time. For larger datasets or more complex models, random search is a better choice. It randomly samples hyperparameter combinations, saving time while still exploring a wide range. Bayesian optimization is another option. It uses past results to predict which hyperparameters might work best, requiring fewer trials. Hyperband is useful when you need to tune many models quickly. It stops poorly performing models early and reallocates resources to promising ones. When setting hyperparameter ranges, think about what makes sense for your problem. Use domain knowledge or previous experiments to choose realistic ranges. For parameters like regularization strength or learning rate, logarithmic scales work well because these values can span several orders of magnitude. Limit the number of hyperparameters you tune at once. Focus on the most impactful ones first, such as regularization or the number of features. This reduces the complexity of your search. During tuning, always use cross-validation. This means splitting your data into parts, training on some, and testing on others. It helps ensure your model performs well on unseen data and avoids overfitting. Set a fixed random seed before starting your tuning process. This makes your results reproducible so you can compare different runs accurately. When possible, run multiple trials in parallel. This speeds up the process, especially when using powerful computers or cloud resources. Track the results carefully. Record metrics like mean squared error or R-squared for each trial. Look for patterns. If certain hyperparameters consistently perform better, focus your search there. Also, keep ethical considerations in mind. Make sure your model does not unintentionally learn biases from the training data, and be transparent about your tuning process. In real-world applications, like predicting user engagement or estimating costs, well-tuned regression models can provide more reliable results. Proper hyperparameter tuning helps these models be more accurate and trustworthy, which benefits everyone involved. To sum up, tuning hyperparameters in regression models is about choosing the right search method, setting realistic ranges, validating carefully, and keeping ethical practices in mind. It takes some effort but leads to models that predict better and are more dependable.